Maintenance is done to ensure that the instrument can function in its best state. Different machines would have different maintenance schedules. Follow a scheduled maintenance according to the instructions given by the manufacturer and record the activity in a maintenance checklist. In addition to the daily maintenance, weekly, monthly, and as needed maintenance should be performed by the lab as per the manufacturer's guidelines. For example, you can see a maintenance chart of KX21 on the screen. Here, the important weekly maintenance includes cleaning of sample rotor valve tray. Some maintenance are performed automatically by the machine on executing commands like auto rinse, whereas some require manual intervention like waste chamber cleaning and transducer cleaning. Some maintenance are authorized for trained laboratory staff, while some are unauthorized maintenance which are done by the service engineer of the company. Please note, do not attempt unauthorized maintenance. Procedure to clean sample rotor valve tray. In this equipment, the sample rotor valve distributes samples and reagents through various channels for analysis. The crystallization of both sample and reagent residue build up on sample rotor valve. The sample rotor valve tray is positioned just below the valve to collect the deposit that may fall off from the sample rotor valve. If the tray is dirty, the debris accumulation hampers smooth movement of the sample rotor valve and can crack the valve. Cleaning of sample rotor valve tray is recommended on a weekly basis on this equipment. Cleaning of sample rotor valve is done once in 3 months by the technical staff. Clean the sample rotor valve tray once a week in this equipment using the following procedure. Turn off the power of the main unit and wait approximately 30 seconds. Open the front cover of the main unit. Remove the sample rotor valve tray. Wash the sample rotor valve tray using tap water. Make sure no contaminants remain, then wipe off the water. Remount the sample rotor valve tray to the original state. Close the front cover of the main unit. Note: when cleaning the sample rotor valve tray, always wear rubber gloves. After completion of the operation, wash hands with disinfectant. If your hands are contaminated by blood, etc., infection can occur. Important monthly maintenance here includes cleaning of the waste chamber and transducer. The procedure to clean waste chamber. Waste chamber collects waste from transducer and mixing chamber. This part also requires weekly cleaning using partially automated process as the operator has to aspirate cleaning solution. When the power is turned on, the message is displayed automatically to instruct the scheduled maintenance on due date. Select Execute Clean on the scheduled maintenance message screen. The Clean Waste Chamber screen will display the message instructing the operation. Set the cleaning solution to the sample probe and press the Start switch in this status. While aspirating is being displayed on the screen, keep holding the cleaning solution in the same position. When the buzzer sounds 2 times, informing completion of aspiration, remove the cleaning solution from the probe. After that, the waste chamber cleaning is executed automatically. When the waste chamber cleaning is completed, the auto rinse and background check are executed. Then the system turns to the ready status. Check to see that no background error occurs. Should background error occur, execute the auto rinse once again. Procedure to clean transducer. In this equipment, transducer houses the measuring part, including the aperture. The cleaning of transducer as part of maintenance is to prevent protein crystallization. Protein deposit will reduce the flow of sample through aperture to give erroneous results. This is a partially automated process. The machine prompts the user for scheduled maintenance on completion of 1 month. When power is switched on, scheduled maintenance message screen appears. Select the option Execute Clean. Fluid in the transducer is drained and the clean transducer screen appears. Open the front cover of the main unit. Open the transducer cover. Using the filler provided by the unit, pour approximately 1 ml each of cleaning solution into the WBC transducer and the RBC transducer. Close the transducer cover. Close the front cover of the main unit. Press the start switch. The transducer cleaning is executed. When the transducer cleaning is completed, the auto rinse and background check are executed and the system turns to the ready status. Check to see that no background error occurs. Should background error occur, execute the auto rinse. Some maintenance procedures are beyond the scope of the lab personnel and have to be done by the technical support team of the manufacturer. These are scheduled maintenance at quarterly or half-yearly intervals, also called preventive maintenance. It is important to remember that routine maintenance can avoid long-term breakdown of the equipment. Both 3 and 5 part CBC analyzers have similar maintenance schedule as per manufacturer guidelines. Details of these need to be understood and followed regularly. The lab should keep some spare parts like fuses, tubings, etc. in the maintenance kit for emergency use, which can be changed by the user. This will prevent longer breakdown time. Documents and records. It is important to maintain records of daily, weekly, monthly maintenance done by the technician, breakdown records along with the service report given by the technical support team, the scheduled preventive maintenance records done by the technical support team. Quality control in automated CBC analyzer. Quality controls are very important part to achieve result accuracy and to monitor the instrument performance. They need to be run before the patient sample at the start of the day, after any maintenance carried out in the machine, after repair of any breakdown, and after preventive maintenance. Quality control. Before running the patient sample, always run quality control to monitor the instrument's performance over time. There are 3 levels of quality controls: low, normal, and high level to monitor different clinical decision levels. Ideally, all levels should be monitored daily depending upon the workload. The NABL recommended guidelines are: the lab will use 2-level controls at least once a day. Labs working for 24/7 will run controls every 12 hours. The quality controls are expensive, have a low stability and a short lifespan of around 10 days. Therefore, it is important to store and handle the quality controls according to manufacturer's instructions. Always check the lot number, expiry date when you receive a new lot of quality control. Note down the date of opening on the vials and QC insert whenever you first open them. Procedure to run the quality control. We will show you a sample quality control procedure using this equipment. It could be different on yours and has to be understood from your equipment manufacturer. Start with QC setting. The QC vial shows the level which is color coded. For example, red is for high level control. The lot number and date of expiry. This needs to be compared with the QC insert, which gives the lot number, expiry, name of the equipment, ranges, and units. Go to Select, then Quality Control. The screen menu shows File Number, Setting, QC Analyze, and Erase tabs. Now select File Number and feed the limits and the target value for all the parameters in the QC file setting. There is a great advantage in running your quality control in the quality control mode. Since targets and ranges are defined, any outlier will immediately be flagged. Many labs tend to run their quality control on sample mode. This is self-defeating and should be avoided. All labs must determine the Westguard rules to be followed as per lab policy, based on the sample load and demands of the analyte performance. Running of the quality control. Take out the quality control vial from the fridge. Leave it at room temperature for some time for the temperature to equilibrate. Go to the Quality Control Analyze in the menu to run the QC. Mix by inverting the vials and rolling them between your palms. Do not put them on the rotor mixer. Open the cap of the quality control vial, set the QC vial to the sample probe and press the Start button. When the buzzer sounds twice in this machine, analyzing is displayed on the control analysis screen. You can remove the QC vial. The QC result will be displayed on the screen. If QC values are within the acceptable range, proceed to run the patient sample. Print the QC values and document them. The records of quality control should be stored for a year. Corrective action. If quality control is out of range, take the corrective action as per the corrective action protocol. This will usually involve rerun of the quality control, auto rinse, performing maintenance of the machine, checking the reagents and calibration if required. Document whatever corrective action was taken in your corrective action log. The quality control plotting. If the quality control module does not support enough data to be statistically significant, the quality control plotting should be done on paper or Excel sheet. Many equipments, including this one, does not support the interpretation of Westguard rules on the graph. This equipment only shows upper limit, that is UL, and lower limit, that is LL, but not the standard deviation, which is required for interpreting Westguard rule violation. The quality control value can be graphically plotted on the Levy-Jennings chart. To record quality control runs for the whole month, plot the Levy-Jennings charts on an Excel sheet, which is explained later. The Labs for Life Levy-Jennings tool is a useful tool to help you track your quality controls easily. Always check your Levy-Jennings chart for the values of data points. Assign the right values. A wrong value assignment can be detrimental. Check the outliers and trends. Monitor the values. Remember that quality control can be your performance evaluator only if you monitor it as per the set rules. Here, on a single day, all the three levels of controls are showing a lower value, suggestive of a random error which needs to be investigated by checking the controls, reagent, and the equipment. When the lab analyzes its quality control data, it must also study the peer group data, which is the mean value achieved by all the labs using the same equipment and controls. Lot verification of quality controls. As per NABL 112, the new lot of control should be run in parallel with old lot of controls. Whenever a new QC lot is procured, the mean, standard deviation and range have to be defined. The manufacturer's range is only a guideline. The lab has to define the range before the quality control is used for monitoring the analytical system. The ideal mechanism is to run the new quality control lot parallel to the current or the running lot for 20 days or for 20 runs in 10 days. This is to capture a fairly robust mean and standard deviation. This mean and standard deviation then is assigned for the new quality control runs. However, hematology quality controls have lower stability and shelf life. The new quality control lot may be verified against the old lot by running parallel for 2 days with minimum of 4 to 6 data points to get the mean. They may use the old CVs to derive the standard deviation using this formula. New lot SD or standard deviation is equal to the old lot CV into mean of the new QC runs divided by 100. Please refer to Quality Control module of the L4L for further details. Documents and records for the quality control should include the QC protocol, daily QC data, Levy-Jennings graphs, corrective action files, quality control insert file, and the peer group data.